All right. Hi,
Hi.
everybody. So we're heckling up the back, so you've heard all our voices already. We're going to be talking a little bit about architecting for the cloud around it, because we sort of hear a lot about elastic, scalable, burstable, all those sorts of things. But unless we think about that in our architecture, we don't necessarily gain a lot. Deploying to a cloud instance, yes, is easier than deploying to a server, but you can go and get just some hosting package somewhere else at a fraction of the price of a decent Azure web role. So the cloud offers us a lot, but we need to keep a few things in mind when we're doing it. So I'm Damian. I'm sort of known as a troublemaker around the place. I know a lot of people in the room already. I'm Damian M on Twitter if anyone wants to harass me. And that's Andrew.
Hi, I'm Andrew. I'm Readify Queensland's other principal consultant. I am the chief asker of awkward questions that you really wish people wouldn't ask. I'm the one who asks why the Emperor is not wearing anything. I'm Ugly Bugger. If you're not following me, feel free to unfollow after today if you wish. Troll, don't troll, it's all good. But yeah, that's us.
And that's the cloud. And that's somebody who knew how to use his cloud. And I guess that's, like I said, that's what we're talking about is, how to use the cloud effectively so that you can, slay evil demons and things like that. Feel free to interrupt at any point in time. We love a good heckle. We'll have some questions at the end, and then we're going to introduce, this is going to be fairly high level. We're going to throw out some, fairly big topics that we won't cover in depth today, but, feel free to come and grab us later on at any time. So with this, we have a couple of case studies of online businesses that demonstrate some of these things. So we're going to talk about those. So, first one, there'll be kittens and memes in here. So anyone who recognises that meme? A few people. Oh, that's a bit disturbing. No one's seen Napoleon Dynamite. Okay, go watch that movie. Okay, so we're talking about Kip's Coffee House. So it's an e-commerce business. So we've got Kip. Kip has a coffee shop. He decides to build an e-commerce website so that people can order their coffee on their way to work, whatever. Look, coming down at 10 o'clock, pay for your coffee, it'll be ready when you get there. And so Kip builds a little website for his coffee shop and pushes it up to Azure. Things are good. So, we need to scale this website. So let's just talk very quickly about scale. There's two ways of scaling systems. One is we scale them up. Yep. And that's our kind of traditional way we scaled stuff before cloud, which was, our site's getting busy, let's buy bigger hardware. So, bigger SQL server, more RAM, more cores, bigger web servers, faster machines, scale it up. I'm losing my sound. Okay, so that's one way. Everyone good with that? Everyone understands that, how we scale systems by buying bigger servers, right? Well, the other way is scaling out. Which is that? Lots of servers. Okay. And that's kind of how we scale with cloud. Is we're not provisioning bigger and bigger and bigger machines because there is a limit. Moore's law kicks in. There's there's only a certain size of machine we can get. Although what can we get in Azure now? 78 core, 3 terabytes of RAM.
It's 112
what do
gig.
you run BizTalk on?
What does it take to run BizTalk fast? Yeah. I think the A9s are 112 gig of RAM and some stupid number of processors, but they've also got some additional thing for fluid dynamics and a few other things now that customizing.
Yeah.
Anyway.
So for most of us, when we talk scale in Azure,
would you try to scale up before you scale down?
Personally? No. And you're about to find out why.
No.
So horizontal scaling is the way we do it with cloud because we can buy lots of instances fairly cheaply. To do that, we need to architect for it. So this ability to scale horizontally is enabled by architecture. Okay?
So here we go. It's a trade between airflow and noise. Sorry, guys.
Is
If anybody starts wilting, let us know and we'll open the door again. Maybe they'll be finished morning tea by then.
All right. So let's talk about Kip's Coffee House. So we have a web server. We have a database server. We have a point of sale system in the coffee shop. And the website also might need to talk to a credit card gateway to take some money and send some emails.
Obviously, this is not a PCI compliance tutorial. Don't actually do that, but never mind.
People do though,
Yeah.
right? You know,
Actually, don't do any of this, but specifically don't do that, but we're not going to cover it.
there are.
External gateway, fine.
Yeah, that's it.
Even then, there are caveats.
Yeah, particularly, we'll store the credit cards in here and make these passwords, and Troy Hunt will come after us. And who got that joke? Only a few people.
Have I been owned? No.
Has anyone seen Troy Hunt's website?
Have I been
Have I been
owned.com?
owned? But he takes in all of the big data and password breaches, and you can search.
Yeah.
And,
Is it, you can search for your own email addresses. So you stick your own email address in and it will tell you, yeah, that particular account's password is compromised on adobe.com or LinkedIn or...
You can even register now.
Yeah, and it'll push you stuff as well, yeah.
I find it when you have it.
Yeah.
If you haven't
Quite
seen
nice.
that, go search for Troy Hunt, Have I Been Owned, because he does a really good blog post actually about how he built it on Azure and how he used table storage. Because he had, you know, millions and millions of email addresses and password things, and how he would go about building that in SQL Server versus how he did it in Azure table storage, and how he saved himself, you know, hundreds of dollars every month by, you know, taking advantage of that architecture. So that's well worth going and looking at, because we're not covering that.
Yes.
But, you know, I've seen e-commerce systems that look like this, okay? And I'm sure everyone else has.
I'm sure you've handed your credit card details
Yeah.
to e-commerce systems that look like this.
And this works, you know, I mean, I wouldn't do it, but, you know, this will work. Okay, so, is everyone with me so far? Who's seen, built, used something like this? Only one person.
we're not going to.
Yeah. only one person's saying
After we're just having a go at the architecture, yeah, who's going to put their hand up?
I know of somebody who did something like that.
I know a guy who knows a guy, right? Yeah. Okay, so this is Kip's coffee shop architecture, and you know, it works well enough. Kip's an enterprising guy though, and he got hooked up with some VC guys and took on some capital investment. So Kip has a win. He's got his retirement plan, all of that. He decides he's taken on $20 million venture capital, and he's going to franchise and sell lots and lots and lots of coffee. So now we have a problem. Does anyone have an idea what that might be?
The POS system.
Sorry? The POS system.
POS systems are always a problem.
Yeah. So let's go back to Kip's architecture. So we now open 400 shops in Australia, and with this architecture. And so we've got lots of customers because Kip does good coffee, or, you know, bad but popular coffee, yeah, which actually tends to be more successful, unfortunately.
It's called Starbucks.
Starbucks, yeah. Sorry.
And a few others. Says Damian, vegan coffee's not.
Says Andrew of Horrors, who left his coffee outside.
So, you know, we need to scale this up. So Kip wants to go, he's on Azure, he's like, right, I can scale, I've got more load, I've got more demand. So what I'm going to do is I'm going to scale this up so I've got 10 of them. Okay? What's going to happen when we have 10 of these in this architecture? And actually, if he's got a POS system in each store, you know, we got 400 of those, 10 of those, what happens? Who's seen it?
What do we have one of?
Well, yeah, single point of failure. Yeah. Okay?
One of.
Everyone's being shy.
Come on.
Come on.
What do we have one of?
A database.
Database.
And what happens when we have lots of things reading and writing to the same database? Deadlocks.
Deadlocks.
Okay, so what Azure gives us is an ability to deadlock at scales that we've never seen before. You can press a button that says, just deadlock me 10 times over, okay?
If 10 servers aren't enough to kill my SQL box, I'll have another 1,000.
Yeah. If you're deadlocking your server with one, you know, we can scale that up. So it's you know, elastic deadlocking. I just made that up.
Well done. I'm going to go fetch my coffee on that note. Be back in a
All right,
second.
on that note. Okay, so we've got now. Deadlock, customer's unhappy, kit goes out of business, no one will order online. Yeah? With me so far? Does anyone disagree with me so far? No? So, I mean, so yes, we can scale that up. Yeah, and that is the first instance. We buy a bigger database server, we put more RAM. So it can process those transactions faster, and that'll get us by for a little while. But it's not really fitting with this whole elastic burstable capacity, because the thing is that Kip sees that he's got, you know, between 8 in the morning and 10:30, they're his busy times. That's when everyone wants to order their coffee. So with Azure, he can say, right, at these times I want this many servers, and then at 10:30 when it drops off, I can drop down to a couple of servers to handle that, just kind of trickle load through the day and save a whole bunch of money. And that's why we like Azure, is so we're not paying for 10 servers, you know, 24/7, 365 days of the year. We pay for the load as we need it, yeah? It's a little bit harder to do that with a database server. Even if you went up to the, what is it, the A9 instance, and then back down, then you have to reboot your database server, and you know, it's not going to be.
Yeah, at minimum twice a day. Yeah, it's going to go well.
Make sense? Okay, so let's look at an alternative architecture. Like I said, we are skimming through this pretty quickly. So here's how we might look at Kit's coffee shop in another way. Okay? And it's all centered around a message bus. So what we might do here is have a whole bunch of web servers, and each one of them might have their own read-only copy of that data. Okay? So we've got lots of data, lots of sort of local databases that we can scale up, or
So
they might be.
Yeah. We push out like a catalog and
Yeah.
all that sort of stuff. You know, things that don't change particularly frequently, but that everyone's going to be reading a lot of or searching a lot of. We push that out to the web server itself. So you want to search for a particular, you know, bean from a particular origin, that's fine. We can scale that out on a particular web server instance. Does that make sense? Yeah. Okay.
Because the sort of right stuff, that, you know, take an order, take a payment, that happens in the point of sale. That's off somewhere else. And that's not affecting these databases. So we can tune these really, really well to reading catalogs. And then later on, when we want to do our, you know, financial reporting, because he's got, you know, $20 million of VC cash, so he's got people breathing down his neck for financial projections every day of the week, he can build a data warehouse off of that as well. And then we can take tasks like sending emails and doing credit cards, we can run them off in a separate process as well. Does that make sense at a high level? Have I started to confuse anyone yet? Really? In that case, we're done, thank you.
Thanks.
So basically what happens in this sort of architecture is an order comes in, and that's a message, and that gets sent on the message bus, and that order event can get picked up by the point of sale and put up on there, look, you know, barista, make this coffee please. Take a payment. That's a message that might comes back in here and into the data warehouse. Or you know, take an order, make a payment, it goes off to the credit card gateway, somebody gets an order, your order is confirmed email. So we basically take events and messages throughout the system, funnel them, you know, through this message bus, and have the work distributed across lots of different nodes. Yeah? So what we can do then is we can scale these up, and we can scale those up, and the work scales nicely too, because, you know, we can use a load balancer to point people at a different web server, and they're pretty autonomous and self-contained. And then the point of sales, you know, you're never really going to overload a point of sale system. Actually, you are, but that's a story I can't tell you. You know, we can have either a point of sale in each store, you know, whatever that looks like, messages go over there. We're probably not going to overload our credit card gateway, but if we are, we can take on multiple gateways. And we just asynchronously push these messages around. Does that make sense? Is anybody that not make sense to? Has anybody done this? Does anybody want to know how to do this? They're all very quiet.
Could anybody actually go and do this now?
Or is
Show of
anybody
hands.
doing this now?
Is anybody doing this right now? Has anybody got code in production, nearly in production, that does anything like this?
I think it's only a
Do you
question of
think
scale
you-
you're talking about. You know, to my
Yes.
mind, don't do that until you're talking about bloody Starbucks or something like that. You know, if you're talking about Kim and he's got 400 coffee shops, sorry, I can do it with 2 databases and without your message bus.
That's an interesting
And
thing.
you know, you've got to decide for the client
Mhm.
when there's value for money in putting the extra time and effort into a more thorough architecture versus doing an in-between one which will probably, you know, best guess last them for their entire life
Yep.
because they aren't going to be Starbucks.
Okay, that's interesting. And I totally disagree with you.
Yeah, I know. And look, that's entirely reasonable, but,
Yeah.
but it's always based on what you've run into in your
Yeah.
life and your experience with your sets of clients.
It's actually really interesting because it's good. Like I like it when I have a talk and I've got some disagreement because then we can actually have a discussion about it. It's really boring when everyone's just sitting here. Because that is a good point. It wouldn't be worth doing this if we had to go all in and spend boatloads of money and time and effort to do this. But it's actually quite simple to do. And there's a couple of other benefits as well, which I'll get to in just a second.
So, can I just throw, what happens with licensing though when you start throwing out on the databases?
Yep.
It's all right if you're not running, but if you're running Microsoft SQL
Yep.
servers or you're watching the POS system.
Yep.
I mean, every time you duplicate,
Yep.
you add licensing costs.
So that's another really good question. So, and one of the, so when I say data, I'm not necessarily talking about SQL Server. Okay, so SQL Server is this great, you know, relational database that brings all the things to the table that a relational database does. Here we are talking about read-only catalog data. Catalog for a coffee shop is going to be, what, 20 products? That could just be a XML file or a JSON file, and you hold the whole thing in RAM. Yeah, and as a change comes through, if we've got, you know, what we would probably have here is like a catalog management app, and when we publish a new catalog, that's a message that gets sent through with a, what, 20K JSON document? Could get sent through to here, and they'll update their cache. So this can be in-memory caches, can be, so yes, it's sort of data store, but I'm not talking about dropping a SQL server on every instance. We've also got a whole bunch of NoSQL options. You could put MongoDB in some of these things. You could put, you know, sort of NoSQL is an interesting loaded term that brings a lot of emotional baggage for a lot of people. To me, it means we don't need to have one source of truth for everything. So you can have optimized data stores for the, you know, the purpose. So we could have, you know, this could be anything over here, and so we're not necessarily paying SQL Server licenses. You know.
And again, tools for jobs. So for instance, if we're not, with a lot of your read-heavy customer-facing, so as in, you know, retail-facing data storage, you know, approaches, it's not necessarily even read, it's more search. And if you start looking at something like search, okay, so it's my customer's going to search for a type of product or a place or a thing, or if you can't pull that into RAM, then you might look at something like Lucene.net, for instance, for really, really fast text search. Or if you're looking for searching relationships between particular types of entities, so show me everything that's connected with this address, which then may map to this entity, which then maps back to another address, or you're looking for, you know, infestation or, you know, plague outbreaks or, you know, flu trends, that sort of stuff, you might use a graph database. Pretty much anything that is read heavy, you would at least consider shipping out to your front-facing tier and optimizing it for those common cases. And you may end up having, you know, a completely different strategy for, you know, back-end queries or, you know, more complicated questions, but optimize for the common case. Optimize to make the common case fast, cheap. And what we can do here, like, so if we've got a, you know, 20 or a 200 or 2 million, you know, product catalog, that's still something that you can just leave in RAM on a web server. You can spin it down, you can bring it back up. We never, ever, ever have to hit SQL for that. So we could have a, you know, Black Friday equivalent sale where we advertise, you know, all of these specials on our website, and we know that all we have to do is scale up the number of web servers. We're not going to have, you know, 5,000 queries per second hitting SQL Server. We're going to have, you know, 5,000 queries split across, you know, 10 web servers, 100 web servers. They're not going to break a sweat.
When we can break away from that single locking point of sort of single truth of data, then we can start to scale in a linear way, which is, you know, what cloud gives us. So this kind of message-centric pattern basically has asynchronous messages that get pushed around, you know, into these discrete services. And, you know, so you can send events and commands from, you know, a front end to some back end service for processing and things like that. So it gives us a bunch of things. We can scale it, we can distribute consumers of that. So we can have, you know, if we've got something that needs to process orders and it's slowing down, we can put more of there, because basically each one of them just takes a message off the queue and does something with it, so we can add more of them. It gives us high availability, because if we've got 2 things sitting there and one of them blows up, you know, we can add another one. You know, if we've got a couple of worker processes on Azure and one of them goes bang and crashes, you know, we can just chuck a new one there, so we get availability. And we get reliability too, so we can go and replay things. You know, if something went horribly wrong, we don't have this snapshotted state of the world. We've got, you know, a queue of things. So if we've got a service that starts going wrong, throwing everything into an error queue, we can replay them. So we get a lot of fault tolerance built into the system because of the pattern that it uses.
So let's think about Kip's Coffee House as an example here, and let's use the original architecture that we were looking at. So we've got a web server talking to a database server. Web server also talks directly to credit card gateway and email gateway. And let's assume for a second that everything's fine except their email gateway goes down. Should people still be able to buy coffee? Okay. What do you think? Should we just stop business because SendGrid accidentally hands over somebody's credentials? Not that that would ever happen. Sorry, did you guys see that the other day? SendGrid got socially engineered, handed out somebody's password change token. Anyway, so because we can't send email, we can't do business. Right? Now that's ridiculous. Right? Why would we have this?
I saw this recently where a web server rebooted after an automatic update, and the SMTP server wasn't configured to automatically start. So all of a sudden, a whole bunch of functions in the website were blowing up with the yellow screen of death because the SMTP server wasn't started.
Come on, who's not been bitten by that? Who has never ever been bitten by that? Really?
Yep.
I have. All right. Now you can design around this. You can design fault tolerance into your system, but then basically what you're going to end up with is effectively a queuing mechanism anyway. Okay, I need to send an email. Well, either I do that inline synchronously as part of my transaction, or I put that task on a list of things to do, and then I will do that list of things in the order that they arrived, which looks suspiciously like a message queue. Right? So one way or another, you're going to end up doing this. And it doesn't matter if your message queue is a SQL table and you just stick an email on the table, or you have a flag in a table that says, yes, I've sent somebody an email. Well, it's pretty ugly. You could do like full table scans and, you know, index scans if you really must. But at the end of the day, what we're really looking for is to treat failure of certain components as a first-class citizen. So failure is not something where if a little bit falls down, the whole system goes boom. Failure is fault tolerance and resilience, allowing our system to continue to operate when things like our email server or our credit card gateway go down, or when we lose half of our web servers, when we lose a bunch of database servers. When this stuff goes just to pieces, we still need to be able to keep business going. And that shouldn't be out of the ordinary. That shouldn't be, oh dear, hand wavy, our email server's gone down, enact the disaster recovery plan. That should just be, oh, well, I guess it'll come back up again after it reboots or whatever. And in the meantime, we don't lose 5,000 orders in that minute. Does that make sense? And the key principle here is we pretty much get this for free. Everybody here can write this kind of fault tolerance into their systems. Right? There's not a single person in this room who couldn't make a fault tolerant system do this. But why would you do it? You're stealing from your client if you write this stuff by hand again and again and again, when you get it for free. You choose a nice architecture that fits what you're actually trying to achieve. You accept that sometimes this will work, sometimes this will fail. We already get retries. Okay, that's fine. Let's just deal with that. Does that make sense?
So it's sort of baked into the pattern, and it's not, when you do it in a small way, it's not something like I said that you need to take on in a really big piece. If you use, you know, we're talking about Azure today, so using Azure Service Bus, it's going to cost you 60 cents per 6 million messages or something. It's basically free. And the tools to talk to it lets you build, you know, get up and running in under an hour. And we're talking about, you know, a little tool that we have vested interest in later on today.
We do, and yeah.
We've done this.
Yeah. And to be fair though, we've done this as a result of seeing a whole bunch of things that doesn't work. So yeah, hit us up afterwards for some actual war stories.
Yeah.
But,
our take on this as consultants is companies call us and say, we've got this system and it is falling apart. Can you come and help us fix it? And we look at, you know, a system that wasn't designed with this kind of fault tolerance in mind, and, you know, customers are coming through the door and literally screaming. With one customer where people are literally coming into the business and trying to punch people because the experience of using their online site was so bad.
You remember your like agile like prioritization metrics? What should be at the top of the backlog? How do we prioritize this?
Let's go through the like priorities with the product owner. You know, anyone that's done Scrum has done that, yeah? I've been in a situation where that is driven by what caused the most people to throw punches this week. And we will fix that one thing, and then we will look at the next one. I've been in that rescue project, and that was great fun.
Literally, the metric was, what's going to reduce the incidence of assault on our staff? Okay. Like, not kidding. Like, it's funny to laugh now, but when you're talking about a 17-year-old kid having someone just lean over the counter and have a go, that's actually really serious. That's actually really serious. So yeah, and this sort of stuff happens. And when it happens, it tends to happen at scale. Right? When we talk about scalability, any kind of software does is allows us to scale human endeavor. That means, just like scaling out deadlocks, we can scale up any mistake we make really, really fast. Okay? If it makes one mistake in 1 billion times, and I just scale it out to 1 million servers, that mistake is going to happen by Tuesday. If that's a bad mistake, then something really, really, it's really bad, but like we delete the universe, but 1 in 1 billion, whatever.
So queues are really the solution to this, because you actually get those 20 people who want to punch that 17-year-old.
And put them in line.
Yeah, line up.
I like it.
Line up. But you also use an event. Brilliant. But you also raise an event. So when it's like, person throws punch, security is called.
Up multiple processes to handle the queue, and you bring your 20 guys in.
Yeah. So, but we've been bitten by this, and that's not to say that a SQL-only architecture is bad or whatever. It is horses for courses. If the course is we have really massive load spikes, we need this kind of scalability, we need the resiliency, we need the fault tolerance, then this is a no-brainer. However, this is not necessarily a more expensive architecture than SQL-only in the first place anyway. Right? And part of this discussion, part of this a whole talk on architecting for the cloud is, I guess, to help people understand that this is actually really cheap to do. It ends up with really cheap, simple, maintainable code, especially if you're talking microservices. You can bring.
That's my next slide, Andrew.
Oh, okay, fine. There you go. Take Damian's thunder. Pocket.
So I mean, the current buzzword for this is microservices. Has everyone heard that term recently? Yeah. So
it's a
some
buzzword.
Some people call it SOA. Some people, currently they're called microservices, and that's kind of come out. A lot of the organisations that have had to scale really, really big, the Facebooks and the Flickrs and the Netflixes and the people that are pioneering like this continuous deployment, DevOps kind of thing, they're shipping very, very fast. And what they've realised is if you have one big giant system, it's very hard to deploy that really, really quickly, dozens of times a day. And the way they've done that is, they break it up into lots of little bits and deploy them. So we don't all have Netflix's problem, as you pointed out, but there's a lot we can learn from it, because they're good ideas. So a microservice essentially is decomposing functionality into small pieces, these small discrete services. And then, some sort of integration with messages or some other way. So there's a couple of other benefits is, our architecture is loosely coupled. So everyone wants to write good OO code that's, loosely coupled code. Yes? No? Unless there's any functional programmers in the room that are going, you idiot.
5,000 lines stored procs. No.
Yeah. So a 5,000 line stored proc with all of our logic in there, including our HTML formatting, that's not loosely coupled. And surely everyone's seen that before. It's best practice, right? So we've got loosely coupled code, we want that. So this is taking that same OO approach to our code and taking it to our architecture. We've got this microservice and it owns this process. Couple of benefits from it, and this comes to your point about not everybody needs to do this. Who works in an organisation or has worked in an organisation where look, we hire people and it's about 6 months till they understand all of the systems so that they can be productive. Yeah, because we've got this one big system. There's a few laughs there. And it's true. It's like, I can see the line, you start, you spend a few days in inductions like this, your workstation, there's Visual Studio, go to work, and you go, right, I'll take a bug off the stack, and it's like, right, this does that, and you see the line of code, and you go, cool, I found the line of code I need to change to fix my first bug in this place. What's going to break when I touch it? I'm not sure. So now I'm going to spend the next 3 weeks tracing back all the code to find out what it touches so that I can safely change that one line of code.
Or you...
Or is that just me?
Yeah.
Am I just a slow down?
Yeah. Yeah. Well, I mean, it usually happens, you know, you're the noob, so you probably get a code review, or maybe you commit and then send a pull request or whatever the workflow happens to be, and you get one of the, you know, one of the more senior guys going, oh, dude, don't touch that. Don't touch that.
For that long, no one's going to. So if we've got these microservices that only do a single thing, the whole thing can fit in your head, and you can look at that code and go, cool, I'll just change it. And we do this. We've got teams on customer sites where we'll have somebody start, and we'll actually say, look, as part of your induction, we're going to drop you into this team for a couple of days. And they'll say, look, okay, you can work on that guy, you're working on this service, it's quite small, it takes this in, and it does this. And you go, cool, it's a little app. Like, little apps are much easier to work on than big ones, right? And the sort of, you know, it's just, they get exponentially slower to change as you get a bigger app. If you're just working on little apps, you can get started really, really quickly because the entire domain of that can fit in your head. So it's a way of scaling your development team. So yes, you might not need to be Starbucks, but if you've got a 5-person team and you need to add a 6th, you can save yourself a whole bunch of money by saying, you're working on that. You work on send the thing to the credit card gateway. You don't have to worry about all of this other stuff. And it's really scalable. Like I said, you know, you need more than one consumer of this command, just chuck some more in. That makes sense? Have I won you over yet?
Not yet.
Not yet?
It's all right.
I'll have to.
I've been doing this a long time.
Yeah. So am I. Not as long as you. It's funny, I've had this conversation this week, and it's you know, it's one of these things like, oh, this is what we thought 20 years ago, and then this happened, and then this happened, and yes, the industry is very, very cyclic, and you know, there was a time where, I mean, you look at Unix, it's a whole bunch of small processes that do the thing and pipe into each other, and then we went, no, that's not good, we want, you know, enterprise middleware, and now we're back to this small thing, and you know, I get that at some point you've seen it all before, but you know, from what we find, this stuff works really well, and you don't need to have to scale for this to work, because we can take, like, we don't need to be Netflix, but you can take the same concepts and get a lot of benefit even with a, you know, a small team.
Yeah. We run small charity projects and a few other bits and pieces where we'll never have more than maybe 2,000, 3,000 users at a time. Now, we could literally run that off an iPhone 4. Like, the whole entire processing load could run off an iPhone. Not a problem at all. The whole lot could run on a Surface. The question isn't about necessarily how the load is dealt with. It's about, you know, all of the other bits and pieces, all of the other features and benefits we get out of doing this. Yes, scalability to respond to load spikes is really, really important, but it's by far the only reason you do this sort of thing. We want the resilience, we want the fault tolerance, we want the decoupling of all of our different system components where it makes sense. If you just scatter stuff all over the countryside, that's not sensible either. But we want to be able to have a sensible, maintainable solution that is going to last a long time. Where bits become obsoleted for whatever reason, maybe somebody invents a next generation credit card that's not a credit card, we can just sub out our credit card and our payment system. We can leave all of the other bits without touching them. The other bits don't need to know about the system. And I guess that's really the core point of a distributed system. It's when my responsibilities are really narrow and really focused, I don't really have that many reasons to change. Right? Think back to your solid principles, right? Single responsibility principle. A class should have one responsibility or one-ish reason to change. Right? If I have to change a thing over here and then have a whole bunch of cascading changes across my entire app or my entire ecosystem, I've not decoupled it very well. That means those changes are really hard, really expensive, they involve a whole lot of testing and a whole lot of risk. If I can just keep things quarantined, if I can say this app actively does not want to know about anything other than what its responsibilities are, that means it really doesn't have to change that much. So when we talk about maintainability, I guess the first criterion is, why would you make me change a piece of code in the first place? Don't write code, don't architect a system that requires lots of different components to be changed in order to add a particular behavior. Does that make sense? Yeah. Like, it's if the easiest part of maintaining a system is just not needing to change it. Yeah? Am I like really weirding people out here? Okay, good.
Cool.
Good. It's all very silent. Yeah.
What unlocks this is, and we've said it before, is we don't need to have a single copy of the data, and that's the kind of this stuff isn't that hard to do. I mean, yes, it's a bit of a learning curve to understand, as a different model. It's not that more expensive to do. What we do need to let go of is this notion that we do have this one, central storage of data.
So in that model, how would you handle like an inventory levels?
Aha, I'm glad you asked. Can I come back to that? Because I have a whole
We have
rant
a
that I'm going to do
real
about Amazon.
analogy for that.
If Amazon was a single database server, they wouldn't be Amazon. They'd be Kids Bookshop, Jeff's Bookshop. So yeah, I'm going to come back to that. That's a good one. And the basic answer is, actually I'm about to do that right now. The basic answer is something we call eventual consistency. Okay? Yeah. Glad you asked, Michael. That's perfect timing.
Thank you. Not a plant at all.
Yeah.
Mr. I work for Damian.
So yeah, that's a really good question. Both, inventory levels, in a bookshop. We're talking about, look, we're going to take this order and then we're going to do the credit card payment and then we're going to go push it into, whether it's the point of sale in the coffee shop or let's look at Amazon, is something that people ask is, well, why don't we have this kind of transaction around it? And the answer is it doesn't scale. Amazon is, what, millions of products, millions of users, billions of dollars in revenue. If we architected that, if you went, right, I'm going to take on Amazon, I'm going to go and download Magneto and put all of my products into it, you're not going to get very far. Magneto's an open source PHP e-commerce thing. Everyone just looks at people. And yeah, so if we went, right, let's chuck Amazon's product catalog into Magneto, it's going to fail. It's actually not going to get out of the gate. But you can imagine if you went to Amazon and you go, right, here's my shopping cart, and now I'm going to make a payment, and then I need to get an email, and then I need to go check the stock levels in the warehouse, and I need to, write into the order table that this is a pending order, and then the page can come back to me. Okay? To do that, I have to put, if I have, a giant relational database, I have to lock the order table, the shopping cart table, the product table, the product catalog table, the customer table, which is going to, trigger. I'm basically locking 27 tables to put my order in for the time that it takes to send an email, charge it, and charge a credit card. I'm locking Amazon. How well is that going to work?
But they don't look the tables.
Sorry?
They don't look the tables.
That's the thing, they don't.
Yeah.
That's, yeah.
I mean, you can't do it. You just cannot scale. You can like lock a 3 million row product table while my credit card gets charged. It's just not going to work. So they don't do it.
So if we were to model this as forgetting about being Amazon, just a paper and physical warehouse bookstore.
That's not a good plan at all.
Yeah.
So
But,
yeah.
So what would our process look like if we took I guess a global synchronization
Yep.
point?
So yeah, if I had a physical bookshop that did mail order, okay, and I got an order in the mail, I'm not going to go, right, everybody stop while I go and deliver that order. That's not going to work. What's going to happen is I'm going to get an order in. If we sort of go 20 years ago, mail order bookshop, I get the form in the mail and with a credit card number on it, and I ring that through. Yes, it's got paid for. Now what am I going to do? I'm going to take some sort of a packing slip to the warehouse. Yeah? So, it might be a copy of that, or I might fill it out. I might have a warehouse packing slip book where I write in customer name, customer address, these books, and I take it out to the warehouse and I put it in their in tray, and the guy in the warehouse picks the next thing up off the tray, and he goes and packs the book, puts it in the parcel, sends it out, comes back and says, I sent order 1, 2, 3, 4 off, and then I might ring the customer or send them a letter or something and say, look, your order's on the way. Yeah, human process. This is how you would run a mail order bookshop at a warehouse. Make sense?
So
That's how it scales online. So if stock levels get low, we're not going to go, oh, an order's come in, everybody stop. -1 on that. So what happens is, they're going to have a pile of books, and the guy, packing thing goes, oh, we're down to our last 10 copies of that. And he's going to go into the guy who orders the books and says, we're nearly out of Biz Talk for Dummies. And they go, okay, I'll order some more. You know, they're commands and messages. Yeah, and this is how real-world businesses actually work. They don't work on this big relational thing. It's like, right, everybody stop work, we got an order. All right, you can keep going again now, which is kind of locking the world. It's about issuing commands and raising events. You know, send an email, we're out of this.
So let's have a think about what happens when we give the warehouse guy a packing slip and he goes to the shelves and says, there aren't any. Like that's so in transactional land, what that really should say is our entire transaction gets rolled back. Right? We undo the credit card payment, we undo a whole bunch of other stuff. We basically say, no, that entire thing failed beginning to end. That's what we'd effectively be trying to do. We'd be trying to undo history. Things that people have done, actions that people have taken. We have charged a credit card. There is no way that we can actually go to a credit card gateway and say, all right, we'd like to pre-authorize this, and then that didn't happen, right? We have to take an auth. For anybody who's familiar with credit card payment gateways, yes, you can have an auth and then a settle instruction, which is as close as you're going to get to a two-phase commit, but it's still not the same as not having done it in the first place. We cannot undo history, right? We can't unsend an email. We can't do all of these things, which means we've effectively broken our transactional boundaries anyway. But there is simply no way to guarantee transactional consistency across this entire end-to-end workflow. And if we try it, then we're just going to build a whole bunch of stuff that just doesn't work. So rather than trying to do that, accept it, embrace it, deal with it, treat it as modeling real-world processes, real-world actions, and allow ourselves to take compensatory actions where things don't go according to plan.
Yeah. So what does Amazon do? They say, look, we shipped these 3 books. This one we've just found out's on back order. We'll ship them when we get it. Should take a week. And you go, okay, cool. Or another thing with Amazon is, look, we accepted your order, but you've got the credit card we've got on file for you is expired. We couldn't take your payment. Log in here, change your payment methods, and then we'll continue your order. So, you know, they've built fault tolerance into their system, and it's because it's not one big locking transactional system. Make sense? So, you know, with stock levels, is what would happen is somebody would say, oh, we're out of stock levels of that, or we're getting low on that. We'll order some more. If Amazon's supplier is, they've got some back order and it's going to take so long, that sends a message back. If you've been on Amazon, then you might see, look, hurry, only 10 orders, only 10 left. Now that's not taking a lock on the logistics system. That's at some point that system is published back that, look, we're low on the stock. Make sense? I won everyone over yet? Cool. We might leave Amazon alone there. And leave scale on there. Happy to talk about this, later on if you want. But yeah, it's basically, look, the world doesn't work in this way, and it's because it doesn't scale. If you were running a mail order bookshop, you would have to break things up into these small tasks where, the guy whose job it is to pick and pack books, he knows that. You give him a bit of data in, he tells you when he's done. We can build systems to model that human interaction, and that scale really well. The reason those mail order businesses worked before internet is because autonomous pieces and it scales. So we need to build, if we build systems the same way, we can scale. If we don't need to scale, we can still build systems that way and we get the fault tolerance. Right?
The really interesting thing about this is humans intuitively get this. When you think about, you ask a team of people to do a thing, right? They will eventually find out ways to have autonomous actions separate to each other. Right? It doesn't matter whether it's a company that's doing mail order books or whether it's a team of people trying to get themselves over an obstacle course or whatever it happens to be. There are autonomous behaviors that will emerge just because this is how humans solve problems. And then we teach ourselves, when we go back to second year computer science, when we learn about Boyce and Cod and all of the other ACID compliant transactions and stuff, and we teach ourselves that the universe can actually be put on hold and then two-phase committed or rolled back. And some of it can and some of it should be, but it shouldn't always be our default. Humans get this stuff, and we've actively unlearnt it as part of our computer science studies, and then we sort of look at it again and go, oh, that's new. It's not new. People have been doing this for thousands of years. Right? You get some people pushing blocks of stone to a pyramid. You get other people lifting blocks of stone up to make a pyramid. Right? That's way, way, way before distributed systems was a term. So
just tried to model the world in UML and it failed.
Yeah. Yeah.
All right. Integration strategies. Another thing we see sometimes is we talk about cloud, and so we'd love to do that, but it's just all too hard. Surely someone would say, we'd love to do cloud, but we can't because we've got some on-premise stuff, or a whole bunch of reasons why we've got. Yeah, it's usually one of the reasons is we don't know how. But often we'll hear something like, look, yeah, we really want to move this stuff to the cloud, but we've got this ERP system or something back here that we can't work with. So another not quite fictional case study is, I'm going to call them Power Plus. No one's laughing at that. Okay, so we've got this company that handles, they're a utility company, and they've got a website where you can go and report faults. So if the power's down in your street or the lights are down in your street, they want to have a little website where you can go and report that. Pretty simple, doesn't need to do a lot, works really, really well. Problem is, when there's a big storm and you get lots of streets out, you have a whole bunch of people looking at it, okay? And a whole bunch of people will look at it and go, oh, my street's on there, that's fine, or my street's not on there, I'll log it, okay? And their system talks to their SAP implementation. So it's really quick, right? That was a joke.
Come on, do we need like a sarcasm font or something?
Apologies. Okay.
Joke.
We all stopped laughing as soon as you meant SAP.
Yeah, it's just not funny.
Yeah. I did see a bit of a collective flinch there. But,
SAP's never funny.
Yeah.
One doesn't simply joke about SAP. So in this, they want to move to the cloud, but it's like, look, we really need to be able to scale this because, when there's a storm, lots of people want to do it, but we've got SAP, how do we do it? Okay? And so really similar looking architecture where we have, a message bus and we've got SAP over here, and then we can sort of put these, scale our web up into the cloud and use the message bus, which if you're using Azure message bus, uses a standard protocol. It's AMQP, tunnels really nicely. And so we can have our listeners back behind the firewall to talk to SAP. Now the thing is that this is a read-heavy system because it only takes one person to, the first person to say, hey look, Smith Street isn't working, and then everyone else is going to read it and go, Smith Street, oh, it's already on there, they obviously know about it, I'll, put my phone down and go find some candles. So this is a really read-heavy scenario. So what we can do is we can move, a read-only database up to there and scale out really, really nicely. So people can read that, nice and fast. They log a message, it sends a message. Put it in SAP, send a message back, update this. You've got a really nice scalable system. That makes sense? And what it does is, so we can keep this behind the firewall because who wants the fun of moving a SAP implementation to the cloud? Not me. And we can still take the benefits of cloud. So if you've kind of got that environment, it's like, oh, we'd love to do cloud, but this is a really nice way to do it. Using these same architecture styles, the same components of asynchronous messaging and a message bus, we can start to distribute stuff really, really easily.
So just quickly on that, who's actually done any sort of SAP integration work? Like hitting SAP web services? Do you need a hug? All right. Who's done it with any kind of load? Who's actually had to do any kind of performance metrics on it? Yes. How many transactions per second are we talking, like read transactions per second out of the average SAP system?
The system that was running about 800.
Yeah. 800 per second? Yeah. That's actually pretty good for most SAP implementations. Yeah, an entire telco's worth probably. Yeah. I mean, I've seen SAP systems for, and I'm not talking itty bitty ones. I'm talking like multinational pharmaceuticals and all sorts of crazy things like that, where we're lucky to get, especially if you're doing things like pricing calculations, you're lucky to get one response every 2 seconds. Now we're talking hardware that costs way more than my house, that costs way more than most companies are worth.
That's good.
Yes, but yes, you're right.
I shouldn't have said that.
Yes, you should. You should.
You're among friends.
Truth is a defense, right? But the thing is, why would you do that to yourself? Now, you're going to get the answer, well, because we need to know, the actual truth at that particular point in time. But what is truth? No. What is the actual consistent view of the universe? So Damian's example. Okay, so is Smith Street currently on the known list of streets without power? No. Okay, Fine. So 2 people in Smith Street may well go and add Smith Street to the, I'm broken, I can't get up list at exactly the same time. We've still got this race condition there. Even if we were going back directly to the source of truth, which is SAP, we're still going to have this race condition. We don't have any kind of guaranteed consistency here. Basically, the world won't pessimistically lock for us. Okay, I can't say, okay, I'm the only one who's allowed to ask if Smith Street is out of power, and then I'm going to tell you. I can't just put a lock on all of my neighbors and say, guys, you're not allowed to talk to Energex or whatever until I'm finished. That's just not how it works. We still have to deal with concurrency problems. We still have to deal with all of these issues. You may as well treat them as first class. So when we move read models out to our frontier, we get all of the advantages of being able to have burstable capacity, especially with Azure websites. You can just turn on auto-scaling. Right? I don't care when there's a storm. I know that I've got 2 web servers or 2 web app instances just sitting there ticking over doing absolutely nothing. And I know that when the sky falls in on a particular suburb or a particular region of southeast Queensland, that Azure is just going to auto-scale my servers up to whatever I need. They're each going to hit SAP once to say, right, load me current state, and then that's it. Right? Load me current state, tell me if anything changes. Meanwhile, I'll go and serve 5,000 requests per second and never bother you again. When the disaster is dying down, it auto-scales back down. We're all pretty cruisy. Yeah?
All right, so we're about out of time. Any questions? And like I said, if anyone wants to get deep into this, we're happy to do it later on. Paul wants to talk again, so yeah.
We should go to it.
You had your first copy slide up,
Yep.
the initial architecture.
Yep.
You had your second architecture.
Yep.
I guess in a practical sense, you can't just go from A to B.
Yep.
What sort of, people, and most people here probably would have a similar architecture as the first one on-prem.
Yep.
And you want to lift that up and you want to drop that up in Azure and have these extra nice things that you just talked about. I guess, what sort of things do you attack first in that scenario? So if you went back to that first slide, what
Do you want to get to it?
after that would you start to lift and drop?
Yep, absolutely. And I've kind of pretty much done that in the past, so I can tell you. So in a situation like this, you'd start to break off these sort of external pieces. So delivering to a point of sale is a really good one. If that's an on-premise point of sale, you've got things like ADSL connections that work pretty well most of the time. But if you're locking while that happens, they can go downhill really, really fast. So you could take the piece that delivers that, it can be a process that lives up here that takes an order confirmed and then tries to push that into a point of sale and then raises a message when it comes back. So rather than holding the custom here, with their page in a locked state, and then just throwing, an exception when it doesn't work, is you can say, right, order completed, and then, watch a database table for, order confirmed, and then watch, poll a database table for order completed. And while that's happening, you're trying to push that in there, and if it takes 30 seconds because some kid unplugged the router for a second and then plugged it back in, you had some, short outage, you could say, right, we've got a 3-minute SLA on getting that into the store before we give up. So, your customer says, right, we've got your order, we're trying to place it in the store, and, that happens in the background, and when it's successful, it fires an event back to say, we're there, and so you could just have like a little Ajax spinner, with SignalR or polling or whatever, and then say, look, wait, yep, we're in, or wait, oh, it's taking a little longer than it should, wait, look, we can't get there, here's the store's phone number, ring them, so you've got that backup process. So those kind of, like, if you break off the pieces that don't need to be synchronous, like sending an email, or the pieces that are likely to fail, you can break them off into little services fairly quickly. And then it gets to the point where, well, now this thing just has to talk to that. Can we make lots of copies of that?
Can we make lots of copies even of little bits of that? So things like, there are actually a whole bunch of queries that I tend to be issuing really quite a lot. Select star from products where name like %, whatever typey %. That's not a SQL injection, it's hack waiting to happen. All right. But that kind of thing, again, that's very, very read heavy. It's very, very frequent. And that's a really, I guess it's a fairly well self-contained use case, right? We can then pick that up and shift it. So what we might do is we might create just a product search service that has a copy of just your product database. and then we might say, well, yeah, that's getting a bit slow.
When that database updates, go send
just
the thing,
push.
go and update your search index.
Yeah.
Another good one is any time where you go, that doesn't change all that often, let's put in caching. You know, caching is an admission that you don't care if data's a little bit stale. So, look, you know, we've got on a really heavy load, we're starting to suffer, let's cache our nav structure or something. It's like, well, at that point we could build something that just had a really nice re-optimize of that, and rather than caching and then going every 5 minutes some customer has to take the hit of, we'll go to the database and pull everything back, that could be, you know, a sort of re-optimized database that gets updated in the background. So yeah, so take out the pieces that are likely to fail, take out the pieces like emailing that you know, it doesn't matter if they're like that or they're 30 seconds later, and then look at places where you might want to cache and pull something up there.
Quick show of hands, if I say DDD.
You're so skeptical.
if I say DDD, domain-driven design, anyone? All right. Concept of a domain event. Yes, no, maybe? Okay. If you have a business rule that starts with the word when, that's an event. That's a domain event. Now, the rules about domain events in strict DDD are that they must be handled synchronously. So let's take the example of double entry bookkeeping. When I put an entry in this column, there must be a corresponding entry in that column on a ledger, right? That's the whole point of double entry bookkeeping. If I can't write the second entry, the first entry must fail. Yeah? If I can't do all of these things at once, then none of these things may happen. Right? So keep an eye out for the word when, and then ask yourself, is that a synchronous event that needs to cancel an entire action, or is that just an asynchronous event? So for instance, when we successfully process a customer's credit card transaction, then we confirm the order in the system. When we successfully bill a customer's credit card, we send them a text message. Right? When their pizza comes out of the oven, we send them a text message saying, hey, pizza dude's on their way. Right? So the pizza comes out of the oven and the text message fails, we don't uncook the pizza. Right? So these things can be asynchronous. So when you hear the word when, that's saying that's probably an event, and your next question is, can I make that an asynchronous event? If yes, then I can probably split that component of my system out into something that just handles that event. Right? So I could have a text message sender that does nothing but sit there and listen for pizza came out of oven notifications. So literally all I do is I listen for pizza's ready, and I say, hey dude, pizza's ready, and that's my job. Right? As a little microservice, how often am I going to have to change? Right? That's really, really simple. And if it does change, let's say I want to change the format of the text message. Okay, I can get a day one graduate developer, and I can say, there's the app. Go and say, rather than hey dude, oh, it's good evening sir or madame. Right? You know, thy pizza is ready. Right? I can tell them to do that. They can ship that change to production in their first morning on the job. Right? That's really, really simple. So you start carving out these little chunks of functionality, and the seams will start to present themselves. The first seam that you're likely to spot is when you see, when this happens, this causally correlated thing should happen, but they're not synchronous. They don't have to happen as part of the same transaction. Does that make sense? Start looking for that, and you'll actually see a whole bunch of just, oh, that's an opportunity to do this kind of things present themselves to you.
Any other questions? You give it back to Paul. Yeah, one.
Yeah.
It might be a big one for later, but
All right.
Maybe.
so how do you handle like globally synchronous events that are time constrained, like customers standing there and like I work for TAT, so it's lotteries. So
Yeah.
you've got a pool of tickets, you can't sell that same ticket twice.
That's, go talk to him
Come
later.
talk to me after.
Yeah, so tickets is something I just thought a lot about. Yeah, there are very few things that are really globally constrained.
Yeah.
When there are, the trick is keep them in a single thread and keep them in RAM, and go talk to Andrew.
Yeah, come talk to me. I've got code that you can play with.
At thank you time.
Thank you.
All right, thank you all.